All right, welcome Algebra 1 students to another Regents review video. This is the June 2015 Algebra 1 Common Core Regents exam. These are going to be the solutions to parts 2 through 4. These are the open-ended short answer response questions towards the end of the exam. All right, so without further ado, let's talk about a few things. First and foremost, if you're here to cheat, get out of here. Please try the problems on your own, then come back here. If you're here to check your answers, or if you're here for some guidance, you are in the right place. Make sure that you hit that subscribe button down below, and make sure that you visit my website at www.nysmathregionsprep.com for much more math content in Algebra 1 and future mathematical subjects in your future. All right. And last but not least, I use a TI Inspire CX calculator. It is one powerful tool, and I will be using it a lot throughout this video. All right, without further ado, here we go. We're doing the part 2s today. Part 2. Here we go. All right, 25 says, graph the function y equals the absolute value of x minus 3 on the set of axes below. So the first thing that I'm going to do is I'm going to create an xy table on the side. And what I'm going to do is I'm going to go to my graphing calculator and type in the absolute value of x minus 3. So go to the button next to the catalog or the book on the TI Inspire. In the middle row, in the first column, that's your absolute value bar. And then type in x minus 3. All right, cool. So now press Control T, and then you get your values here. So what I'm going to do is I'm just basically going to have like a table that's not too long, that's not terribly long. I'm going to do this. I'm going to do 0, 3 first, and then go to the right. 1, 2, 3, 4, 5, 6. And I'll tell you why I'm not doing the left, because you should know that the absolute value function in this case has a slope of 1 over 1. Just like this. So if I were to graph all these, and it extends, look, in this direction like that, and same thing to the left, it looks something like that. All right, so now I'm just going to draw arrows on both, well, I'm going to draw lines, arrows on the ends, and, oops, my apologies. There we go, like that. I want a blue thickness there. Does that work? Yes, it does. All right, and that is your absolute value. I'm now going to label it as y is equal to the absolute value of x minus 3. Then it says explain how the graph of y equals the absolute value of x minus 3 has changed from the related graph y equals the absolute value of x. So if you just go to your calculator and you type in the absolute value of x, how did the blue, like, what did it do? Well, it moved to the right by 3 units. So all you're going to say in your explanation is you're going to say y is equal to the absolute value of x minus 3 was translated 3 units to the right. 3 units to the right. In relation to y equals the absolute value of x. And that's about it. That's all you have to do with that question. All right, pretty simple stuff. Simple graph. All right, let's go on to number 26. Alex is selling tickets to a school play. An adult ticket costs $6.50 and a student ticket costs $4. Alex sells X adult tickets and 12 student tickets. Write a function, f of x, to represent how much money Alex collected from selling tickets. So we're going to say that f of x. Now, we know that one adult ticket is $6.50 and one student ticket is $4. Now, he sold 12 student tickets. So that means he sold $4 times the 12 student tickets. He sold a total of $48 in student tickets. Okay? So what we're going to do is I'm just going to take $6.50 times X plus the $48 that he sold in student tickets. So that's your answer. F of x is equal to $6.50 times the amount of adult tickets that we don't know plus $48 for the student tickets. All right, that's how you do question number 26. Moving on to 27. John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x equals 60 plus 5x. The total amount of money Sarah will save is given by the function g of x equals x squared plus 46. After how many weeks, x, will they have the same amount of money saved? Explain how you arrived at your answer. So it says same amount of money. After how many weeks? So go ahead and set them equal to each other. So 60 plus 5x, set it equal to x squared plus 46. So now I'm going to subtract the 60 and the 5x because your goal is to set this whole equation equal to 0. So we get x squared minus 5x minus 14 equals 0. Now you got to figure out what adds to negative 5 and multiplies to give you negative 14. So that is going to be x minus 7, x plus 2 equals 0. So now we do our t-bar. X is equal to 7, x is equal to negative 2. Since x is weeks, and since there's no such thing as negative 2 weeks, this could be rejected because it is considered an extraneous root. So, 7. So now we need to figure out, well, we got the value of x, and then it says explain how you arrived at your answer. So what we're going to say is John and Sarah will have the same amount of money saved after 7 weeks. And how you do this, and this is your explanation piece, set both functions equal to each other to find this value. And that's it. So 7 weeks. After how many weeks? So that is your answer. 7 weeks. All right. That's how you do that question. And that's about it. All right. 28. If the difference 3x squared minus 2x plus 5 minus x squared plus 3x minus 2 is multiplied by 1/2 x squared, what is the result written in standard form? Wow. So what you need to do first is you actually need to perform this indicated operation up here first. Okay, so what I'm going to do is I'm going to multiply everything inside by the negative. I'm going to distribute that negative. So we get 3x squared minus 2x plus 5 minus x squared minus 3x plus 2. Now I combine like terms. So now we get 2x squared minus 5x plus 7. Now it's saying multiply that answer by 1/2 x squared. 1/2 x squared. So I'm going to distribute right in. So what we get here is we get, well, 1/2 times 2 is just 1. X squared times x squared is x to the 4th. 1/2 times negative 5 is negative 5/2. X squared times x is x to the 3rd. Plus 7 times 1/2 is 7/2 with an x squared carrying along for the ride. And that, ladies and gentlemen, is your answer. Now remember a couple things. Remember a couple things in order to get this right. When you're multiplying, you always multiply the coefficients and you add the exponents. As you notice, I multiplied all the numbers and I just added the exponents. Like, for example, 2 plus 2 is 4, so that's where I got x to the 4th from. All right, moving on. 29. Dylan invested $600 in a savings account at a 1.6% annual interest rate. He made no deposits or withdrawals on the account for 2 years. The interest was compounded annually. find to the nearest cent the balance in the account after 2 years. So again, you need to know A of t is equal to p times 1 plus or minus the rate raised to the t power. Now, since this is interest, we are using a plus function because his account is increasing in value. So your A is what we're trying to find because it says find to the nearest cent the balance. We're trying to find the balance. The principal is how much is invested. He invested $600 in his savings account. The rate is 0.016 expressed as a decimal. And your time is 2 years. Okay? So we're going to plug all this information in. So we get A of t is equal to the principal of 600 times 1 plus 0.016 raised to the second power. Type this into your calculator. So go to your calculator. Type in 600 times 1.016 raised to the second power. There is $619.35 in his account. So A of t is equal to $619.35, and that is your answer. That's how much money is left in his account after 2 years. All right, star that answer, and that's it. All right, question 30. Determine the smallest integer that makes negative 3x plus 7 minus 5x is less than 15. True. So what we're going to do is we're going to solve for this first. I don't really care about the smallest integer part yet. I need to solve this immediately. So negative 3x and negative 5x, I don't know why they did this. They just made it more convoluted and complex. They should have really combined these first. It's actually negative 8x plus 7 is less than 15. All right, so just that one extra step. We're going to subtract the 7 on both sides. You get negative 8x is less than 8. Divide by the negative 8 on both sides. Now remember, when you divide by a negative, you need to flip the inequality sign, and this will give you negative 1. So x is greater than negative 1. So it's saying determine the smallest integer value that makes this true. If x has to be greater than negative 1, so your job is to say that the smallest integer that makes this inequality true is x equals 0. That, ladies and gentlemen, is your answer. Because negative 1 is considered not included because there's no equal sign underneath the greater than sign. So it has to be x is equal to 0. That is the next integer above negative 1 that would satisfy that condition. 31. The residual plot from two different sets of bivariate data are graphed below. Explain, using evidence from graph A and graph B, which graph indicates that the model for the data is a good fit. Okay, I need you to look at this. Look at graph A. It's all scattered. Look at graph B. I could draw a pattern. So your answer for this case is going to be graph A. So you're going to say that graph A is a model for good fit data. Now it says explain. So by explaining, you're going to say that graph A shows the range of the residuals to be approximately plus minus 0.5. And the reason why you see that is look at the difference of numbers on the left compared to here and then compared to here. It's only a few tenths of a place. These are whole numbers over here. This is only a few tenths of a place. So these are quite close to each other. So we're going to say that graph A shows the range of the residuals to be approximately plus or minus 0.5. Okay? The range in graph B indicates a much larger range, meaning that it is not a good fit model. Okay, so you could say that, or you could say that graph B shows a pattern which is not a good fit. So any one of those answers would be perfectly acceptable on the exam. All right, and that's how you do this question. All right, moving on to question number 32. A landscaper is creating a rectangular flower bed such that the width is half of the length. And then it says the area of the flower bed is 34 square feet. Write and solve an equation to determine the width of the flower bed to the nearest tenth of a foot. So here's what I'm going to do. I am going to let x equal the length. And I'm going to let 1/2 of x equal the width, because she's saying that the width is half of the length. So remember that the area of a rectangle is length times width. Just keep that in the back of your head just as you're going through these questions. Now, she tells you that the area is 34. So just take 1/2 of x times x and set that equal to 34 and just solve for x. So 1/2 of x times x is just 1/2 of x squared is equal to 34. Now to solve for x, you're just going to multiply by its reciprocal of 2/1. Those cancel. You get x squared is equal to 68. And then you take the square root of both sides. Now when you type that into your calculator, the square root of 68, that is approximately 8.246. So x is approximately equal to 8.246. So now the question is asking you for the width. So the width of the flower bed is equal to 1/2 of x, which is equal to 1/2 of 8.246, which is approximately equal to 4.1. So we're going to say as our answer that 4.1 feet is the width. The width. And that is it. Done. Okay. Moving on to the next question. Now we're into the part 3s. Now it's getting good. Part 3s. All right, 33 says, Albert says that the two systems of equations shown below have the same solutions. Determine and state whether you agree with Albert. Justify your answer. So this is going to take a little bit of time just to complete the process. Now, I'm going to try the first system down below, okay? Now, if we have 8x plus, actually, I'm going to do it in the center. If we have 8x plus 9y is equal to 48, and 12x plus 5y equals 21, we need to cancel out one of those variables in order to solve for the other one, because we can't solve for two variables at the same time. You just can't do it. So what I'm going to do is I'm going to cancel out my y's first. So what I'm going to do is I'm going to solve for x by canceling out my y's. I need to multiply the top and the bottom functions by a number that could cancel out the y values. Now, 9 and 5. The least common multiple of 9 and 5 is 45. So I'm going to multiply the top by 5, and I'm going to multiply the bottom by -9. Now, I'm going to distribute in. So what we get here is we get 40x plus 45y is equal to 240, and we get -108x minus 45y is equal to -189 when you plug those values into your calculator when you multiply them. Those y values now cancel. So 40 minus 108 is -68 with an x carried onto it, is equal to 51. Now in order to solve this, we just divide by -68 on both sides. Okay, so we get x is equal to -3/4. Okay, when that is simplified. So from here, now what we have to do is now we need to solve for y. How do we do it? Well, we take -3/4 and we pick one of these equations and we plug in -3/4 for x. So I'm going to take my equation I'm going to take the equation 8x plus 9y equals 48. Okay? So if you plug it in, we get 8 times negative 3/4 plus 9y equals 48. 8 times negative 3/4 is just going to be, let's see, negative 6 plus 9y is equal to 48. I'm going to now add the 6 on both sides. You get 9y is equal to, looks like 54. Divide by 9 on both sides, and then you get y is equal to the value of 6. So your ordered pair for the first system, the solution to this system, is negative 3/4, 6. That is the ordered pair. Now, the second system, I promise, is much faster. If you take this second equation and you divide by negative 8.5 on both sides, look at how fast this goes. Y is equal to 6 because negative 51 divided by negative 8.5 is 6 for y is equal to 6. So if you take 6 and you plug it in for y, look at what happens. You get 8x plus, well, 9 times 6, that's just going to be 54. So 54 is equal to 48. Subtract the 54 on both sides. You get 8x is equal to, what is that equal to? Negative, hold on. Oh, I'm sorry. I wrote that wrong. Negative 54. There we go. That is going to be negative 6 divided by 8 on both sides, and then you get x is equal to negative 3/4. Oh, look at that. It's the same solution. That is also negative 3/4 comma 6. So determine and state whether you agree with Albert. Justify your answer. Your answer is going to be yes. Albert is correct. Both systems have a solution of negative 3/4 comma 6. And that's it. You are all done. That is a lot of work. Yeah, certainly a lot of work. You probably can't even see that on your screen. But if you need to rewind, please do so. Now, I'm going to show you really fast. You could you could put these into your calculator by going to Menu, Algebra, Solve System of Linear Equations, and just type these in. So if you type in the first system, which is 8x plus 9y equals 48, and remember that this is only for checking purposes, so you can't justify this on the Regents exam. You actually have to show work. Negative 3/4 and 6. So now do it again. Go to Menu, Algebra, Solve Systems of Linear Equations. Do it again for the second set. So 8x plus 9y is equal to 48. And negative 8.5y is equal to negative 51. Press enter. Okay, and again, okay, so negative 0.75. The reason why it's in a decimal form now is because negative 8.5, if you have a point in there, then we'll put it to you in decimal form. But it is the same solution, so we are done with that question. Moving on. Number 34, the equation to determine the weekly earnings of an employee at the Hamburger Shack is given by W of X, where X is the number of hours worked. Determine the difference in salary in dollars for an employee who works 52 hours versus the one who works 38 hours. So they're testing your knowledge on where do you plug in 52 and where you plug in 38. 52, you need to plug into the second function, and 38 goes into the first function up here. Because if you look at your domain right here, the domain for this is 0 is less than or equal to x, which is less than or equal to 40. 38 hours lies in that domain. And if you take 52 and you plug it in for here, it lies in this domain. So what I'm going to do is I'm going to find W of 38 first. So W of 38 is equal to 10x, right? Because that's the equation that we are using. So we established that we're using 10x, which is equal to 10 times 38 hours. That's $380. Now we're going to find W of 52, which is equal to 15 times x minus 40 plus 400. So that's the equation that we're working with. So now we get 15 times 52 minus 40 plus 400 and you make 580 bucks. So it says determine the difference in salary. So it's just going to be $580 minus the $380 because difference means subtraction, and we get $200 is the difference. Now determine the number of hours an employee must work in order to earn $445. Explain how you arrived at your answer. So, watch how this works. The first thing that you need to establish is which equation are we using. Watch how I do this. Try 10x first and see if it works. If you take 10x and set it equal to 445 and you divide by 10 on both sides, watch what happens. X is equal to 44.5. Look at the value of x, ladies and gentlemen. It lies outside of the domain. So that means that you are not allowed to use 10x for this question. You are forced to use W of x is equal to 15 times x minus 40 plus 400. There's no other option. You have to use this equation or else you are going to get the answer wrong. So, put in 445, set it equal to 15 times x minus 40 plus 400. We're going to subtract the 400 on both sides. So now we get $45 is equal to, I'm going to distribute that 15x, I have to extend the page. 15x, let's see, 15 times negative 40. What the hell is that? 15 times negative 40, and you get negative 600. So, negative 600. I'm now going to add the 600 on both sides. You get 645 is equal to 15x. Divide by the 15 on both sides, and you get x is equal to 43. So, it says determine the number of hours an employee must work. So, you're going to say the employee must work 43 hours because you let W of x equals 445, then solve. And that is how you explain your answer, and that's how many hours that the employee must work in order to make that money. All right, 35. This is a long Regents for the part 2s. This is insane. 35 says, an online electronics store must sell at least $2,500 worth of printers and computers per day. Each printer costs $50 and each computer costs $500. The store could ship a maximum of 15 items per day. On the set of axes below, graph a system of inequalities that models these constraints. So the first thing that I'm going to say is I'm going to let P equal printers, and I'm going to let C equal computers. And now I'm going to set up a system of inequalities. So you could take the printers plus the computers is less than or equal to 15 because you could only ship a maximum of 15 items. So the printers plus the computers, you could only ship a maximum of 15, meaning that you could ship at 15 or below 15. Now, it costs $50 per printer plus $500 for a computer, and you want to sell at least, meaning greater than or equal to $2,500. Of course, you want to make more money than $2,500 when you're selling these things, right? So now what we're going to do is we're now going to graph these. So you need to make sure that you have a good range of numbers. So what I did is I counted by 5s down here. 5, 10, 15, and then 20 over here. And then I counted by 5s up here as well. So 5, 10, 15. All right, so here we go. I'm going to graph the first inequality, which is P plus C is less than or equal to 15. So the y-intercept is 15, and you go down 1 to the right 1 each time. So keep on going until you reach the very end. So down 1 to the right 1 each individual time. And it should stop at 15. Now, I'm now going to graph my line. And keep in mind that it does have to be solid. because it is less than or equal to. So equal means it has to be a solid line, and we are going to be shading below. Actually, you know what? I'm going to save the shading till later. Make it a little bit neater. So now I'm going to graph the inequality 50p plus 500c is greater than or equal to 2,500. Now, if you graph this, the y-intercept is going to be 5, and your slope is down 1 and to the right 10. So it's all the way over here, and then you do it again. So it's kind of a weird looking line, but it does work. So we're talking about this line right here, and that's if you graph it into your graphing calculator. So now I'm going to label this as 50p plus 500c is greater than or equal to 2,500, and over here this is p plus c is less than or equal to 15. Now you're shading. You shade below for this one, and you shade above for this one, and this is your solution set in here. Okay. So it says, determine a combination of printers and computers that would allow the electronics store to meet all of the constraints. Explain how you obtained your answer. Ladies and gentlemen, there are many combinations that you can have to meet the constraints. But I chose this. I said 5 printers and 7 computers meet the constraints. All right, and explain how you obtained your answer. Any and all combinations that lie in the solution set in the form of P comma C will satisfy. And that's it. That's all you have to do. All right, we are almost done. I'm getting tired of this. 36. An application developer released a new app to be downloaded. The table below gives the number of downloads for the first 4 weeks after the launch of the app. Write an exponential equation that models these data. So you should know that the standard form of an exponential equation is y is equal to a times b raised to the x. Input these into your calculator. If you go, I don't want that. If you go to, sorry about that. That shouldn't be there. Get out of here. Okay. If I go back to my graph, my graphing calculator, and I go to my list in spreadsheets, and I click here, and I say number of weeks, and I click on, and I type in number of downloads, and I type in these numbers. So 1, 2, 3, 4, 120, 180, 270, 405. Okay, so go to Control Doc, add a calculator, menu, statistics, stack calculations, exponential regression. Where is that? A. Exponential regression. Your X list is number of weeks followed by number of downloads. Click OK. Your A value is 80. Your B value is 1.5. Okay, so your A value is 80. Your B value is 1.5. I'm going to expand this a little bit. All right, there we go. Those are your values. Why did I do that? Hold on one moment. Sorry, I just erased all that stuff by mistake. A times B to the X. A is 80. B is 1.5. Okay, so write an exponential equation. It's just y is equal to 80 times 1.5 raised to the x power. And that is your answer to the first part of this question. Now the second part says, use this model to predict how many downloads the developer would expect in the 26th week if this trend continues. Round your answer to the nearest download. So all we're going to do is we're going to take our equation, which is y is equal to 80 times 1.5 to the x, and I'm going to let x equal 26. So we have 80 times 1.5 to the 26th power, and that will give you 3,030,140 downloads, and that is your answer. And that is rounded to the nearest download. So 3,030,140 downloads. Okay, and then, would it be reasonable to use this model to predict the number of downloads past 1 year? Explain your reasoning. This question bothered me a lot because it's just a stupid question. Would it be reasonable to use this model to predict the number of downloads past 1 year? No. And the reason why the answer is no is this. The popularity, and I know it's ridiculous, but the popularity of apps can change. Now, I use an actual real-life example to explain my answer. Now, I don't know how many years Common Core is going to be around, but I mean, I'm just so curious. If Common Core lasts for like 10 years, and this video is this video will be out till YouTube will probably be around for a very long time, but this video will stay out for a very long time. But I mean, I don't know if 10 years from now students will be watching this. Who knows? But I use a real life example of Flappy Bird. So I said Flappy Bird. That was a good app. I freaking loved that game. Flappy Bird and balls, if you know what that app is, if you pull and the balls go around and you hit the blocks, Flappy Bird and balls are no longer popular. It's not that Flappy Bird's not popular anymore. They took it off the damn App Store, which I was so upset about. But it is what it is. Life goes on. And that's how you could explain your answer. The popularity of apps could change. And if you want to throw in a real-life example, by all means, go ahead and do it. All right, the final question of this Regents, and I am done. All right, 37. A football player attempts to kick a football over a goalpost. The path of the football can be modeled by the function h of x is equal to -1 over 225x squared plus 2/3 x, where x is the horizontal distance from the kick and h of x is the height of the football above the ground, where both are measured in feet. On the set of axes below, graph the function y equals h of x over the interval from 0 to 150. So I actually need to create a domain and range for this. So on the left-hand side, I actually need to write this like this. I need to write on the left-hand side feet, which is h of x. And I need to take this, move it over here, and spin it around. Okay, so this over here is measured in feet. Now, it says... Okay, well, I'm going to get back to that in a moment here. And then it says from 0 to 150. So this is 0. I'm going to go every 2. So 10, 20, 30, 40. My head's probably blocking the way, but I'll change in a moment. 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, and then 150. Now, if you graph this into your calculator, and if you were to graph that and get a table of values, that would be awesome. But the problem is that there's so many values that you have to select wisely. You have to select whole numbers. And I'm going to do that right now. I'm going to go to my calculator, and I'm going to graph -1 over 225 x squared plus 2/3 x. And I get... Now, it doesn't even look like a parabola, but you actually just need to change this range to, the domain to 150, and then change the top to about 30-ish. And that is your parabola. So it is a quadratic. So if you do Control T and you just start graphing. So 0, 0. Well, of course, because you need to start on the ground somewhere. So 0, 0, and you just keep on going. The next point that would be great to put is the next whole number, which is 15, 9. So, oops, what is this? No, not that. So 15, 9. Keep on going to the next whole number. 30, 16. 30, 16. Keep on going. 4521. 4521. And keep on going. Just keep plugging away. It's going to be fine. We're just going to graph these. So 6024. 7525. Oh my goodness. 9024. Okay, so it looks like that now these values are going back down. We just have to find the x values that satisfy those things right there. So let me just keep on going. Unfortunately, you do have to show work, so this would be considered work. So 105.21. And do it again. 120.16. 135.9. I think that's the last one, so I hope. 150 should be 0. Yeah, so 1e to the negative 12th, that number is so small, it's considered to be the number 0. So 150, 0. Great. Now your job is to graph these. Now, notice here that your feet or your height doesn't pass the number 30. So what I'm going to do is I'm going to actually count up 2, 4, 6. I'm going to count up by 2s. And I'm going to go all the way up to 30 and stop at 30. Okay? Now I'm going to graph these. 0, 0. 15, 9. 30, 16. 12, 14, 15. 16's about there. 45, 21. Whoever came up with this question is insane. 22, 24, 75, 25. All right, 90, 24, 105, 21. It's about there. 120. That's right there. 135 and 9. That's right there. And 0, 0. Sorry, 150, 0. So I do apologize for my sketching because I am on a computer here, so it's going to be a little messy, but I'm hoping for the best. So I'm just going to take my time with it, but it should be a quadratic. That's not that great. But that'll do. Okay, that's good. So I'm going to label it as h of x is equal to negative 1 over 225 x squared plus 2/3 x. Great. That's that. Now it says here, to the next part, it says determine the vertex of y equals h of x. Interpret the meaning of this vertex in the context of this problem. So the vertex in this case is up here, which is the point 75, 25. That means 75 feet away. By the way, oh, I forgot. I failed to label this. This is in feet, and that's your domain. 75 feet away from the starting kick, it reaches a maximum height of 25 feet. So you're going to say that the vertex is at 75, 25. All right, and this is the highest point during flight of the football. Great. Last but not least, the goal post is 10 feet high and 45 yards from the kick. Will the ball be high enough to pass over the goal post? Justify our answer. What made this part tricky is they all of a sudden put it in yards. Your units are in feet, folks. So that means 45 yards. Well, how many feet are in a yard? Well, 3 feet are in a yard. So 45 yards times 3 feet will convert it into feet. That is equal to 135 feet. So if the goalpost is 10 feet high at 130, look at this. At 130, the goalpost is 10 feet high. Which is, hold on one second. 135, not, no, wait, hold on a second. I just said 130? No, 135. So at 135, yeah. 135 is 10 feet high. So that red dot is the goalpost. They're asking you, will the ball be high enough to pass over the goalpost? Justify your answer. No. No. Look, the goalpost is higher. The ball passed underneath the goalpost, according to the graph. So we're going to say no. The football goes under the post because, and you could actually use a height to justify this, because 9 is less than 10. At 135, it's at 9 feet. The goalpost is 10 feet. So therefore, since 9 is less than 10, that is your answer. All right. That is the conclusion of this video. That was a long video. I apologize for that. But I hope that you learned a lot from it. Make sure you hit that subscribe button down below, and make sure that you visit my website at www.nysmathregentsprep.com for more math content, and I will see you real soon.